Okay, this question is a fair bit harder than any that we've done videos for before. It's wanting to find the equation of the perpendicular bisector of a line joining the points 0, -4, 6, 5. I've done a rough sketch here. Here's the 2 points. There's 0, -4 there, and there's the point 6, 5 there. I've done a line joining those 2 points. But what it wants the equation of the line that it goes through the middle, so the midpoint. We need to find the midpoint of that line, and it wants the equation of the line that is perpendicular through that midpoint. So I've represented that by the dotted line. So it wants the equation of the dotted line, a line that goes through the midpoint of our original line and it's perpendicular to our original line. So what we need to find to do this is the gradient of this original line. We then find the gradient of the perpendicular line. We then find the midpoint of the line, and then we have enough information to write the equation. So let's find the gradient of this original line. So this line going from here up to this point, so this line here. We write down our gradient formula. The gradient is y2 minus y1 over x2 minus x1. I go to my 2 points, I'm going to label them x1, y1, x2, y2, and then substitute in to my formula. So y2 is 5, subtract -4, x2 is 6, and I have to subtract x1, which is 0. So the gradient is 5 subtract -4, which is 9 over 6. That's my gradient. I can simplify that because 3 goes into both. The gradient is 3 over 2. So that is the gradient of our original line. So we'll gradient 1. So we've done that. The gradient of a perpendicular line. So the second thing we need to do is what is the gradient of the second line, the dotted line. We need to remember that m1 times by m2, for perpendicular lines when you times the gradient together you get -1. If the original gradient is 3 over 2, the easiest way I find the gradient of a perpendicular line is I flip, so change it to 2 over 3 and then change the sign. So if the gradient of the original line is that, the gradient of a perpendicular line is that. So we've done point 2. Now we need to find the midpoint of our original line. Midpoint formula, capital M, x1 plus x2 over 2, y1 plus y2 over 2. Now if we go back up here, remember 0, -4 was our x1, y1, and our second point, which was 6, 5, that was our x2, y2. So sorry, that point there was 6, 5. So let's substitute those in to work out our midpoint. x1, 0 plus x2, 6 over 2. y1, -4 plus y2, 5 over 2. Substitute it in, now work out those. That is 6 over 2, and that is 1 over 2. And of course 6 over 2 is 3. So that's our midpoint. So I've done step 3. Now, step 4, write the equation. So I've got this point, and remember the gradient of the second line, the line we're wanting to write the equation for, the gradient of the second line is -2 over 3. So I have got 1 point and the gradient. So I use the formula y minus y1 equals mx minus x1 and substitute in. So it's y minus, and here's our point, our x1, our y1. So y minus a half, subtract a half, sorry, is equal to -2/3 x subtract 3. Yeah, I'm right there. So y minus 1/2 is equal to negative 2/3 x plus 2, because I've multiplied that by that and that by that, negative, negative, positive, and here 2/3 times 3, 2/3 times 3, cancel, cancel, that's how I got the 2. Now, remember, equation of a line, this is the form I'm wanting it in, y equals mx plus c. Aiming for that form. So I need to add 1/2 to this side, so that cancels. So I add 1/2 to this side. So y is equal to negative 2/3 x plus 2 plus 1/2 is 2.5. So that is the equation that we are looking for. A lot of work, right? So we had to find the gradient of this original line here. By finding that, we could work out the gradient of the perpendicular line. The line went through the midpoint of our original line, so we needed to find out our midpoint. And then we had one point, the midpoint, and the gradient, which gave us enough to work out the equation.